Hi, everybody. The work that I'm going to present now is a joint work done in collaboration with Arianna Soldati, which is the student who worked this topic in her master thesis, and Deliana Nikolic and Elena Benvenuti, who is the PI and coordinator of the PMO-GATE project. So quick overview of my presentation. I will quickly illustrate motivation, production work, and then the concept of multi-hazard. We will see what the Promethee method is, why we are in our work, and then we will apply this procedure to a case study that is the province of Ferrara. So what we are basically proposing here is the use of the Promethee method to qualitatively assess the multiple risk condition of a given region, so on a regional scale, and we are going to apply this procedure to the province of Ferrara as a case study. And let's say that in this case, the multiple risk is basically a combination of the risk from earthquakes, so seismic risk, and the risk from floods, so hydraulic. I will very quickly go over the motivation of this work, which is basically the PMO-GATE project, which has been already mentioned in the presentation before mine. So I won't spend many words on this, just to say that it is a cross-border project that seeks to enhance safety and reliance for tester due to natural hazards. And the main output of this project will be a plan of risk management aimed to overcome emergency conditions with the least possible social and economic impact, and the development of early warning system to enhance safety and resilience. So the region interested by this project is the Italian Adriatic coast and Croatian. So we are experiencing an increase in natural disaster, which means that there is a higher exposition to multiple risks and a need for new tools and methodology. From this need, new challenges arise. So in this case, our aim is to develop a new methodology for a multiple hazard assessment of the combined seismic hydraulic risk in the territory of Ferrara. So we want to be able to answer to this question: which areas are the more vulnerable to earthquakes, floods in our region? So where is Ferrara? Ferrara is sitting in the Po Valley in North Italy, and you can see here the province of Ferrara is a province of the Emilia-Romagna region. And you can see that it is made of 21 municipalities. Biggest municipality is Ferrara, which is also the main city, of course, of this area, of this region. As usual, the risk is defined as a product of hazard, vulnerability, and exposure. And of course, if we are talking about multiple risk, we must think of multiple hazard and multiple vulnerability. Here you see two pictures because our territory has been recently struck by a strong earthquake, May 2012. Here you see the consequences of this earthquake. And then, since we live in proximity of the biggest river in Italy, which is the Po River, we are also prone to floods, but not only for the presence of this main river, but also because of the presence of many other minor water courses. So what is the Promethee method, and how do we think to apply it to a multi-risk assessment procedure? Basically, we want to solve a problem in the form maximize or minimize a number of criteria based on a given number of alternatives. So we call G the criteria, A the alternatives, and in an ideal case, we would like to maximize. We would like to find an alternative which is able to maximize or minimize all the criteria. Of course, in the real world, it's almost impossible to find an alternative which is able to maximize all the criteria or minimize all of them. So the idea of the Promethee method is of computing a preference function for comparing two alternatives. Let's say that the alternatives are A and B, and then we define a function B, which is the preference function, which takes value 0 to mean indifference from the two alternatives, 1 to mean a strict preference of the first alternative over the second one, and the more the function takes values near 0, the more the preference of the first alternative over the second is weak. Then we can sum over all the criteria to get the so-called global preference index of alternatives over another one. Once we have computed the global preference index for all the alternatives over all the alternatives, we are ready to compute the so-called positive or negative outranking flow, which is an index which basically sums up all the global preference indexes and tells us how much a given alternative outranks or is outranked by all the others. Once we have computed both positive and the negative outranking flow, we can compute the net outranking flow, which basically allows us to produce a ranking among all the alternatives. As you can see, this ranking will depend on the particular choice of the preference function and the weight W, which is assigned to each criteria, to each criterion. And so let's go to our case study and let's see how we use this methodology in practice to compute multi-risk analysis of this territory. Our case study, as I was saying, is the province of Ferrara, which is basically a flat land with negligible slopes, and which is characterized by the fact that over the 40% of the territory is under the sea level. This means that there is quite important risk of flood, especially in the lower portion of the territory. And then the hydraulic characterization of this area is made of basically the Po River, Reno River, and Panaro River, which are main rivers in this area, and then and the Cabo Napoleonico River, which is another artificial river, very important in the area. And then we have a set of minor water courses, which made up the Hydrovia Ferrarese system, which is a capillary net of courses which serve the country, the activities, the agriculture, the area. So on the other hand, as for the seismic characterization, we use basically the PGA map of the area, which gives us the peak ground acceleration on each zone province. And in particular, we can see that the highest PGA, the highest ground acceleration, is in the southern part of the province, and whereas the northern part has ground acceleration is a little lower. As for the basically the PGA tells us how much is the seismic hazard of the province. On the other hand, we look as for the hydraulic hazard, we look at the maps that have been produced by the Emilia-Romagna administration, which distinguish the hazard into 3 levels of hazard gravity. And basically, we translate this map into a municipality hazard, because we decided to work at the municipality level, so that we define for each municipality of the province a given level of seismic hazard, a given level of PGA, and a given level of hydraulic hazard, so a given level of flood for each municipality. And we work at these levels from this. As I was saying, the seismic hazard is given by the peak ground acceleration in each municipality. And we then have to define the vulnerability index for each municipality. So for each sub-area which we have divided the region of interest. And since we are working at a very macroscopic scale, okay, we are not looking at the single building. We have, as a start, defined the vulnerability as an index related to the age of the buildings, assuming that modern buildings are more suited to resist to earthquakes because of the presence of seismic regulation. And so this is the outcome of our subdivision of each municipality into a given level of vulnerability. Then we relate the exposure to the population density. So for each municipality, we define the level of population density, and this is our index of exposure, even if we can also add more indexes of exposure, for example, presence of strategic buildings and so on. This is our final matrix of variation of the Promethee method. You see the alternatives, each row, and the criteria in each column. And then, as a preference function, we choose a type 1 preference function that's defined as this portion. Basically, it's a step function, which takes as an input the difference between two criteria. Between the same criteria computed over two different alternatives, and takes value 0 if the difference is less than 0, and 1 if the difference is greater than 0. And then we take the weights equal for every criterion. And then we performed a sensitivity analysis. So we changed the preference function and as a type 5 preference function, and both the 0 max or mean standard deviation options are investigated in this case. And we also propose different scenarios for different choice of weights for each criteria. And these are the results. So basically, we have subdivided the whole territory into high risk, medium risk, low risk. And this is the outcome of the ranking of the Promethee algorithm. You can see that the higher risk, in the sense of multiple risk vulnerability, are the area around the municipality and the area in the southern portion of the region, mainly due to the presence of high peak ground acceleration. On the other hand, the lower risk areas are the one beneath the Po Valley, Po River, and also the coast. This is the results. These are the results of the sensitivity analysis to the preference function, usual preference function, the 0 max, mean standard, and you see that basically, aside from little changes, the main ranking doesn't change so much. So on a regional scale, we got quite a robust result in terms of subdivision to high, medium, and lower level risk. And finally, this is the sensitivity analysis to the wave choice. And even in this case, we see that the main conclusions are still valid. This sensitivity analysis is needed because since we are applying arbitrarily the weights and the preference functions, we need to know how the results are sensitive to this choice. So basically, what's the main thing that we found out? The multi-criteria decision analysis is a novel and innovative tool for multi-hazard risk assessment at regional scale. It allows to enlighten the areas of given territory more prone to combine seismic risks in order to suitably define the intervention priorities. And it has been applied, this procedure, to the case study of the province of Ferrara. Of course, we need further investigation, especially with respect to sensitivity to different model parameters. And the difficulty of this model is mainly due to data acquisition and processing for the whole region, whereas we have a great high flexibility and adaptability to stakeholder needs, who are the final users of this tool. Of course, the limits of the procedure are the qualitativeness of the result that we obtain, as well as the data availability and the possible causal chain effect and chain effects between the risks which are not yet considered in the approach that we are proposing now. So I thank you very much for your attention.